Hey guys, in today's video I'm going to be fitting an electrical outdoor socket. This video is going to be jam-packed with tips and tricks, and hopefully by the end of the video you'll feel confident enough to tackle this job for yourself. I'm not just going to be showing you one but 3 different ways of installing these outdoor sockets to maintain a completely watertight seal and maintain the IP66 rating of these boxes. So if we take a closer look at this demo board I've made up, I'll show you the 3 different ways you can do this job. So we'll just spin this around for a moment. Obviously you've got your exterior wall right there, you've got the cavity in the middle, and then the interior wall on this side. You drill a 12mm hole through the wall and put your twin and earth through the hole, and then I've got a 20mm master seal twin and earth grommet sealing that outdoor socket. The second method is drilling a 16mm hole through the wall. This is 15mm PEX pipe, and then I've put a 15mm coupler on the end again to keep the outdoor socket watertight. And then the third method is drilling a 22mm hole through the wall. This is 20mm conduit with a male adapter on the end, again keeping the outdoor socket watertight. So with the first method I seal it with a 20mm twin and earth grommet. With the second method I use a 15mm coupler with a 1/2 inch back nut. And the third and final method, I use a 20mm male conduit adapter, and that seals the box off nicely. With these 2 methods here, you will have to get a 25mm drill bit and recess the hole about 30mm deep, and that's just to accommodate the couplers, so the socket outlet will fit flush to the wall. And I just want to demonstrate here how well these 15mm couplers actually fit. It gives you a really secure tight fitting, and it keeps any water out. So you screw it in, you get your 1/2 inch back nut, screw it down, and then obviously you'll pop your 15mm PEX pipe into there, and that'll give you a nice watertight fitting. Anyway, that's enough talk, let's get on with installing one of these outdoor sockets. So the first thing we want to do is figure out where we're going to take the power from. So I'm going to be putting my outdoor socket on this wall right here, and lucky for me there's an interior socket on the other side, so that's where I'm going to be taking the power from. So once you've figured out what circuit you're going to be taking the power from, there's 2 very important jobs to do. Number 1, you want to isolate that circuit safely, and the second job is to ensure the circuit is on an RCD. So let's go ahead and go do that now. So here is the interior socket we're going to be taking our power from, and I'm going to be using a socket test adapter to ensure that we isolate the power properly. So my consumer unit is in my garage, so all I do is turn each circuit off one by one until the audible tone stops, and then I know it is that circuit. There you go. Then you want to make sure the circuit that you're taking the power from has an RCD protecting it, which is protecting that bank of circuits, so we're absolutely fine. So as illustrated by the 2 arrows, you can see exactly where the RCD is and the circuit we're taking the power from. So this is absolutely fine as our circuit is protected by the RCD. If on the other hand our circuit was over on the left side now, we'd have an issue as that MCB is not protected by an RCD. You also want to make sure no one else can get access to this consumer unit and turn the power back on, or use an electrician's lock-off kit. If the circuit you're taking power from is not protected by an RCD, one way around this is to upgrade it with the relevant RCBO. An RCBO basically has the features of an MCB and RCD integrated into one unit. This type of work is probably best left to an electrician, however there is an easier way of doing this for a competent DIYer, and I'm going to show you that now. So you can actually buy outdoor sockets with an RCD integrated into the socket, and you just install this like you would any other outdoor socket. It complies with regulations and gives you that level of safety required. You also have test buttons on the front of the outdoor socket, and you want to use these periodically to ensure that the outdoor socket is operating how it should. And the other option you have here is to use an outdoor fuse spur with an integrated RCD, and you could then go ahead and link that into a standard outdoor socket. So again, this will give you the RCD protection required. and it also gives you the ability to safely isolate that outdoor socket from the rest of the circuit should there be an issue. The main takeaway from this, guys, is whatever way you do it, make sure you do it safely and that your outdoor socket is protected by an RCD. Now that this socket is safely isolated, let's go ahead and take this base plate off. So all we need to do is just take the screws out. And then you can just pry the socket face down. And you can't be too safe when dealing with electricity, so let's just double check and make sure the circuit is in fact dead. And as you can see, it's safe to work on. Now it is worth investing in an electrical testing piece of equipment, even if it is just a voltage pen. Something is definitely better than nothing. So next up, I'm going to undo these terminals here and I'm going to take this socket base plate off. Next up, I'm just going to temporarily put these Wagos onto these conductors. Don't know if you can see this on camera, but there's a 20mm tab right there, and we need to pry this out with a flathead screwdriver. Once you've worked the tab loose, you can just get some pliers just to pull it out with. So next up, I'm going to be drilling a 12mm hole through the wall with this 12mm SDS drill bit. I'm going to be doing it at a slight downward angle so the moisture goes out of the building and not into the building, and I'll be pairing that with my Milwaukee SDS drill. And it's always a good idea to wear some PPE when doing this type of work. So as you can see here, I begin drilling at a slight angle. Now I'm on the second layer of brick. I've actually measured 3.5 inches and put a tape mark right there. So once it hits the 3.5 inch tape mark, I'm going to take it off hammer action, and that will prevent the brick from getting blown out at the other side. And with a bit of luck now, we should have a nice clean hole on the outside. Let's go ahead and take a look. And look at that, straight through the mortar joint. Perfect. Now going back to our outdoor socket demo board I made up earlier on, I'm going to choose to go for this method here. Reason being, I think these other two methods are a little bit overkill and kind of unnecessary. I just wanted to demonstrate you can do it in many different ways, but I'm going to be selecting this method right here today. So what we want to do now is prepare our outdoor box for installing onto our wall. So I draw a 20mm hole straight through the centre of the box, and then I get a 4mm drill bit and I drill into the centre of each corner. So go ahead and offer the box up to the wall. I just make my first mark using a marksman pen there. Then I drill a 6mm hole into the wall. Then I get a 6mm red raw plug and I pop it in with a hammer. So the screws I'm going to be using today are these stainless steel screws, as they don't rust. They're also flat at the bottom of the head rather than the countersunk screws, so they clamp and seal the boxes better. And I use this really handy Armic bit driver, which has a magnet on the end so it holds the screw nicely. And I find using an impact driver rather than a drill better for driving the screws in. So first thing I do is just drive one screw into the plug just to hold it in position, and I can level it out. Then I get a 4mm masonry drill bit. and I go ahead and mark the other 3 holes. Then I get my 6mm SDS drill bit and I drill the remaining 3 holes. And now just get the rest of your 6mm plugs and hammer them in one by one. And now I grab a length of 2.5mm twin and earth cable and push it through the wall. Then strip the outer sheath of the twin and earth cable. Now before we go screwing the box onto the wall, what we want to do now is run a bead of clear silicone in these channels. And what that will do is help seal the box and make it completely watertight. So here is my clear silicone. Little tip here is once you're done with it, pop a screw on the end there and that will keep it fresh. And now go ahead and start dispensing the clear silicone into the channels. Once I've done that, I then get my twin and earth grommet and install it into the box. And now push the twin and earth cable through the grommet for a nice watertight seal. Then you want to begin screwing the box onto the wall. And I don't drive the screws all the way in with the impact gun, I nip it up with a screwdriver at the end. If you go too crazy with the impact gun, you can damage the box. Next up I get some clear silicone and pull it in the little channel where the screws sit. And with this particular box you get some rubber bongs, and what these are designed to do are go over the screw caps and prevent any water getting into your box. So just set that into the clear silicone. And that's the last one in place. Then strip your wires down and then you want to double these over. So just get a pair of pliers to do this. And you want to do the same with all 3 wires. Then pop your earth sleeving on. And like I said, we're going to double over all 3 wires including the earth. Perfect. And the reason why you double over your wires is it just allows it to make better contact with the terminal screws of the outdoor box. So now insert your earth wire into the earth terminal and tighten down the screw. Same with the live. Tighten it down. And then finally the neutral. Same again, tighten it down. Once you've made the terminations and there's no conductor showing, like so, you can then pop the socket face onto the back box. Now lift the lid up and get a flathead screwdriver and turn the screws clockwise to lock the faceplate to the back of the box. Job's a good one. Let's now go inside and finish our terminations off. So again, strip the twin and earth sheath and pull it off. Then strip the insulation off the individual wires. Pop some earth sleeving on. And now I'm going to replace the faceplate for one simple reason. This one has Wago style connectors on the back and it's far easier to terminate the connections. And it's clearly colour coded, so you've got your neutral, your earths and then your lives at the end there. So I just quickly split my earths, it'll be easier to terminate the connections. And then I begin by terminating my live connections. And as you can see, look how easy it is to terminate. They're just little levers that you pop down and it makes a connection. Now moving on to my earths. And then finally the neutrals. Job done, it's as easy as that. So let's now reattach the faceplate to the back box. And it's just a case now of popping the screws back in and switching the power back on at the consumer unit. There's just one more job left to do, guys. Have a nice cold one, you've earned it. That's about it for this video, guys. Thanks very much for watching the video. If you liked the video, please consider liking and subscribing to the channel, and I'll catch you on the flip side. See you later.